Good morning, interweb. Spec Biolog 4. We are, as always, continuing to world build our fictional planet here, placeholder named Kretak, cramming it full of cute little critters. Last time around, we began work on our ancestral plant body plan, this cheeky chappy here, artwork by the wonderful Van Gogh, links in all the usual places. This time around, I want to redo the plant body plan, slightly take into account some of your wonderful suggestions from the previous video, which, FYI, if you're new here, you're going to have watched said previous video before watching this one, otherwise nothing will make any sense whatsoever. We'll do that and then we'll wrap things up by talking about changes to the naming scheme. So that's the preamble done, let's fix up some autotrophs, shall we? Okay, so the first and most important thing is the alternation of generations. As a quick recap, we discussed the plant style alternation of generations and the fungi style alternation of generations. I opted for the former just because that's a safe bet. Earth plants do this, but I was wondering if we could do the latter, the fungi style alternation of generations. Plenty of discussion and comments about this, and you know what? I think you guys have given me the confidence to kind of plow ahead with this. So we'll make a switch. We will switch to fungi style alternation generations. That means our plants will look like earth plants, trunks, leaves, branches, that kind of thing, but under the hood they'll function like fungi, which I think is pretty cool. So the updated life cycle will look something like this. We have our distinct male and female plants because we want a dioecious body plan. These are haploid, the gametophytes, single copy of the chromosome. More on that in a little bit. Female makes egg, male makes sperm. Fertilization occurs. A diploid organism will be formed, which we'll reduce down to microscopic irrelevance in our modern forms. This diploid, the two copies of the chromosome, will make a whole bunch of spores because it's a sporophyte. And then based on the environmental sex determination, these spores will germinate, if that's the correct word, into either a male or a female, and the cycle repeats itself. Oh, and also, we wanted asexual reproduction, so as well as sexual reproduction, we also have this, just to really double down on the amount of arrows here. So these gametophytes, if for whatever reason sexual reproduction doesn't happen, they can asexually produce another gametophyte. So that, in theory, is going to be our body plan life cycle. But last time we talked about how this life cycle has, or a negative consequence of this life cycle, having a gametophyte dominant phase. Is that because if you only have a single copy of the chromosome, no masking occurs, so potentially deleterious mutations just get put into the system straight away, which may or may not be a good thing. I don't fully understand this. But folks in comments, lots of people in comments, brought up polyploidy. This is a thing, a condition, if you will, where instead of having two sets of paired chromosomes like we do, you have more than two sets. 3, 4, and I'm pretty sure some organisms have just bucket loads of them. Hello, Editor Edgar here. I just want to jump in with a brief tangent because I just found this page here. List of organisms by chromosome count. I've not read through this page at all, so how about we together discover just how mental the world of chromosomes can get. So we got our chromosome number here. This is low to high. Let's sort it high to low. Wait, hold a second. Wait, what? The ciliated protozoa has 16,000 chromosomes. Calm all your baps, Mr. Ciliated protozoa. That's ridiculous. Wait, what? Macronuclear nanochromosomes ampleploid macromosomes times 1900 ploidy level. Wait, so it has 1900 copies of 16,000 chromosomes for a total chromosome count of 2.964 times 10 to the 7 chromosomes. What's that? That's just like 30 million chromosomes. No, surely not. I don't know about you. I reckon some researchers catwalked across their keyboard while they were researching Mr. Ciliated protozoa, because that is wild. Oh, and then there's this fella here, the black mulberry, 308 chromosomes. Has the highest ploidy among plants, so it's 22 ploids, so it's 22 copies of whatever amount of chromosomes it has. Oh yeah, each somatic cell has 308 chromosomes in total and exhibits tetraploidy, 44x apparently. So its genome contains 7 chromosomes and each body cell has 44 copies for a total of 308. Yep, 7 times 44. Maths checks out. Boy, that's you, my friend, are an overachieving little plant, aren't you? Anyways, but back to the video. So I speculate, again based on comments and a little bit of reading, that maybe we could kind of nerf the negative consequences of this sort of life cycle by introducing polyploidy. So instead of there being n and 2n, what I'm going to say, and I'm not going to specify this very far because I'm not interested in getting into genetics because it's way outside my wheelhouse, we're going to say that there's just x copies of chromosome. However, that x is greater than 2. However many, doesn't matter. And then in the sort of haploid, although maybe these terms now are kind of relevant, we just have x divided by 2. We just have half that. And this should help with the masking because we have more than one copy here, sort of like a safe backup copy if something goes wrong, which maybe, again, speculating, maybe this could be a decent justification for why these organisms stick with gametified dominant life cycles, where on Earth that was switched out in the sort of like higher plants. The higher plants switch to a sporophyte dominant life cycle. Maybe having this condition means that they don't need to make that switch, which would be pretty cool. So assuming that isn't, paradigm breaking or something, that's what we're going to do. Which means we're going to need to redesign the design, if you will, from the last video, because we specifically designed this organism to have a plant-like sporophyte stage and a very unplant-like gametophyte stage, because we wanted the sporophyte to become dominant. We now want the reverse, so we're going to have to design a very plant-like gametophyte and a very unplant-like sporophyte, which thankfully I don't think is too hard to do because we could just lean on horsetails, these fellas here. And that should allow us to kind of keep a lot of the things we wanted from the previous video, but just update the system, if you will. So I'm thinking something like this. A single stem with a bunch of nodes and little like non-vascularized proto-leaves. A horsetail, if you will. And just to give it a size, just cause, let's say that this fella is 8 to 10 centimeters in height. Yeah, something like that. How delightful. And I need to remember we have a male and we have a female version. Let's keep them looking basically the same in the body plan stage. We didn't want terminal sporangia. We don't want the gamete sites at the tip of the organism, so I want them along the body of the organism. So we'll say at or in and around the nodes, just like last time. Water comes, because we're thinking of these organisms as living close to water, as kind of early plants did. Water comes along, yeets the male gametes, they get transported over to the female, they'll land on her gamete sites here, and then fertilization will occur, and I think from this location, the sporophyte will grow. So the sporophyte is dependent upon the gametophyte, so we just need to design, I guess, how that looks. So I'm thinking something like this. So we zoom in on this section here, there's our node, we imagine our gametes are in here somewhere, and after fertilization occurs, this little kind of very delicate tendril grows up out of this location, and it's tipped with like a packet of spores, and it's all very flimsy and weak, such that the next time a big gust of wind comes along, they break off and the spores are dispersed to a new location and we make a new plant. How delightful. The circle of life, folks. And I think having it like this, also this isn't to scale. I don't know exactly how far these things would extend out, but having it be like this, I think leaves us open to reducing the sporophyte right down into microscopic irrelevance and just doubling down the gametophyte. I like that. I think that's okay. So assuming all that tracks, that is how this plant does sexual reproduction. We should also think a little bit about how this plant does asexual reproduction. And I think here's a good opportunity to lean heavily into kind of how fungi do things. So I'm thinking we have our plant. Oh, and all of these plants are going to have little like proto-roots, the rhizome things we talked about before. How delightful. There we go. I'm thinking if sexual reproduction doesn't happen for whatever reason, or maybe this plant is in an uncolonized area and it just wants to spread really quickly, it could switch on asexual reproduction, and much like fungi, or at least we'll get to what fungi do in a second, it could send out a little root along here, and then somewhere along this root outgrows a new asexual copy of this plant. Delightful. And maybe at a later stage, not in the body plan, but at a later stage, we could say that this sort of strat is turned from asexual to sexual, in that there could be another adult plant in the vicinity. Let's say somewhere over here. Actually, let me just copy it. Hold on. So there's another adult over here. Let's say that this boy was female and this boy was male. Instead of doing this asexually, maybe both plants reach out to their roots, they touch, there's an exchange of genetic material, and a new sexual plant is formed. This is what fungi do. So maybe some lines do this underground reproduction stuff, which I think is kind of fun. And leans further into the fact that these kind of behave a little bit like fungi. So with all of that in mind, what I want to do now is I just want to sketch out like a quick cladogram just to get a very broad overview of where we're going to go with these things. And obviously as we develop further, we can flesh it out more. Okay, how about this, right? So we have our body plan, this guy. Early on, there's a split. Some bios keep the original life cycle of the body plan. This chap here with specifically haploid diploid phases, so N and 2N. And we'll say that these do really well at the start, kind of like mosses and stuff. Very good at colonizing the early terrestrial environment. But once kind of the very early terrestrial environments are kind of full up, one innovative group here switches to the polyploidy sort of thing that hopefully affords further complexity. They go on to vascularize, so lignin will form, shrubs, trunks, trees, etc. Oh, FYI, OG here means outgroup. Anyhow, the vascularized ones, they'll go on to reduce the sporophyte down to microscopic relevance. Basically almost get rid of this guy, leave it as a vestigial sort of thing. And then from here, it's very much Earth-like, as in seeds will be developed, so wind dispersal, so they can colonize further inland, and then eventually animal dispersal will be innovated. Basically the same shtick as what happened on Earth. But over in our early ones, like we'll call these like our bryophytes, we have this root sex idea occurring here. This stuff, which we can kind of think of as almost like kind of like internal fertilization, if you will. I get that that's like an expedient term in this context, but it's just how I have it in my head. That will further help differentiate these two groups. So this group here, if you're doing underground internal fertilization, scootly pooping, you're likely in this family. If you're doing above ground, air quotes, internal fertilization, scootly pooping, you're likely in this guy, as will be the case for a modern tree. Again, we can kind of think of this as internal fertilization because the plants literally join gamete sites. And these will be pretty diminutive, again, like bryophytes, because they haven't got the polyploidy going on, but these will be where our complex trees will form. And speaking of which, our modern tree, which we just saw there, probably will fall somewhere along there, I think. So that feels good to me. It's probably all wrong, but at least it makes me feel nice. Anything left to do outside of that? I don't think so. I believe the checklist remains the same. Yeah, pretty much. It's sessile, it's asymmetric, or at least its descendants will be asymmetric. This guy's pretty symmetric. Non-segmented, those nodes don't count. Gas exchange, all the sort of crack happens just like plants, through the fusion, through the leaves. They are teal in color, but probably the whole stalk is also teal in color. Both sexual and asexual reproduction, it's dioecious, and it's anasogamous, I think, and it relies on environmental sex determination. Okay, that is our plant body plan. Yeah. I like it. I'll ship that off to the wonderful Vanga Van Gogh, links in all the usual places, and he will almost certainly create some tasty looking artwork, which you've almost certainly seen from the thumbnail. All that's left to do now is talk about the changes to the naming convention. Folks, I enter into this next section with great trepidation. So I need you to come with me into the next section with an open heart. Okay? Let's talk naming convention changes. Okay, so in episode 2, I had said that we're going to call all the organisms by Greek names, specifically ancient Greek names. And lots of suggestions came flooding in, which I really, really appreciate. But the problem was, as I went through all these suggestions, I kind of wasn't feeling it. And after a lot of soul searching and, chatting to a whole bunch of people about this, I think the problem with it, and if I'm to reduce it down to a singular sort of thing, is that I have no connection with ancient Greek. And I only went with the ancient Greek because that's kind of the done thing. Standard Linnaean nomenclature, Latin or Greek, dislike Latin, so get rid of that, just go with Greek. But yeah, Greek means nothing to me. So I thought about some more and was like, I should go with a language that means something to me. Now there are 3 options here. There's English, for obvious reasons. There's Irish, because I'm half Irish, and there's German, because I'm half German. Although I considered English, that's a no-goer because it's just kind of boring. The lesser spotted tree frog doesn't sound great. Irish is also a no-goer because, for me anyways, the Celtic languages are they give a sort of fantasy vibe to them. thank you Tolkien, which is kind of not really appropriate for the setting, and the orthography in Irish is an absolute disaster, and I would not wish studying that orthography on like my worst enemy. So Irish was out, and then German. So German was interesting to me, and the more I thought about it, the more I'm like, I think German is the way to go. And I think there's two strong points to this. Or actually, there's three strong points. One, we've already talked. It means something to me. It's personal. Gives me a chance to kind of explore my sort of the language of my ancestors. There's precedence for German being used in kind of sciencey contexts. I think kind of physics, and mathematics and the like. There's tons of German everywhere. You know, Gaussian blur, Gauss, German, Einstein, Max Planck, Kepler, Leibniz, Euler. Although Euler was Swiss, I believe, but Euler is a Germanic or German root. I think it means potter. Leonhard Euler. Leonard Potter. So there's some precedence there. It can give sort of sciencey vibes. And this might just be me, but I think German has a sort of future, or can have a sort of futuristic vibe to it. And also there's a fourth option why I think German is great. People tend to dislike German. I think German gets unfairly maligned as like a air quotes ugly language, which is just so not true. So I'd like to do some agitprop for German. So all these things considered led me down the path to go, do you know what? German names is the way to go for me. And so the kind of in-universe reason for this is, remember the website, artifacting.com, links in all the usual places, is written from the perspective of the alien observer race, but is being transcribed by a future Earth scientist. We just say that the future Earth scientist is German. And so he's, littering in German terms every now and then when there isn't an appropriate established term. I think that works and makes sense. And to give you a sort of flavor of what we're doing so far, the patrons and I have been going through and relabeling all of the Star Trek placeholder names, giving them proper Germanic names. So the galaxy, Uhura, used to be called Uhura, is now called Vulcanspor. It's got this code up here, which is a big old Easter egg, so can anyone unpack that? But Vulcanspor means cloud trail. Our animal body plan, relevant to this series, Blasenkrone, which means bubble crown. The star is called Quell, which means source. The planetary system, is called the Quell system. The planet itself is called Torwelt, which means gate world. The moon is called Vechta, which means one who guards. And the little Mercury analog in the system is called Motte, moth, as in it flitters around a light source. So I'm really digging this aesthetic. I really am. I appreciate it's not going to be everyone's aesthetic, but it means something to me. And I think that's important. So if you would like to hop on the Germanic train with me, I guess, grab a beer, don your lederhosen, and get on your highly dysfunctional train system on a Sunday where everything's shut and get down with the German. If not, I totally understand if people don't like this. And the final thing before I go is that I've found in working with the patrons on replacing some of the placeholder names that dialogue is kind of very important to this process, in that people make suggestions, I make counter suggestions, we kind of, we hash out ideas together and come up with something cool at the end of the day. YouTube is not a great place for that dialogue to occur, and really Discord is where it's at here. I have this name suggestion channel on the patron-only side of the server, where we can really hash things out. So I think most of the work is going to be done here. So if you're interested in getting down and dirty with us, consider signing up to the Patreon. Links in all the usual places. If not, of course, feel free to just leave suggestions in the YouTube comments. Hopefully, not everyone hates that. Here we are. So, a Germanic name for our ancestral body plan? Let's be having it. Alright, that is the video. Thank you so much for watching. Massive shout out to the patrons for supporting the channel. Shout out Vanga Van Gogh for all the wonderful artwork. Links in all the usual places to Vanga's stuff. And of course, as always, massive shout out to Bibloridian, mentor extraordinaire. Everything I know about biology comes straight from Bibloridian. And a lot of the ideas that you're going to see in this series have been workshopped with Bib. So without him, none of this would be possible. Please go like, please go subscribe, and if you can, please go support Bibloridian on Patreon. Alright, that's us. Until next time, Edgar out.